So as you might see, I left that this is the presentation from PyCon PL 2024. It was 2 months ago. Normally it will be not so a big problem, but as you heard, it happens many things. I hope that I spot this was changed, but there might be something that I missed when updating the presentation, so I left this information because, you know, there were changes even in these 2 months. I will be talk less about general Python packaging, more about the problem of the dependency pinning. Because we know that from one side, if we left without any pinning dependency, we got random crashes, especially when we create new instance of environment, because some new packages might come. From the other side, if you pin dependency to very old and do not update it anyhow, it ends that after 2 years, you have hell. Because so many breaking changes that you don't even know where to start. So the best is to have a pinning, but update it weekly or even more often, because there are only small changes, 1 to 5, 1 to places, not all project. Okay, so who I am? I'm assistant on the MIMO faculty at the Warsaw University. My main time is spent on the Napari core development. Napari is the Python native viewer for n-dimensional data. Comes from biological background where you have big images that are 3D, 3D plus time, sometimes terabytes of size, and so on. But ability to have it in Python is you could just put your script and try to process data and see what it is. So this is mainly for rendering images and annotation over the images. But people are using it in the same way. I'm also CI build wheel maintainer. The CI build wheel is the tool that you might want to use if you have package with binary extensions. Because this is the way to set up the environment to build your package in the way that is easy to upload to PyPI or other registry and have no problem with working on almost all machines, because there are still some problems, but all common problems should be solved. Okay. So in the context of whole dependency problem, we have problem library contra application or some special, more specific project. So what is the requirement for library? It should work on the multiple Python version. It should work on the multiple operating system. And so it means that you expect it to work with multiple versions of dependency. Because it might happen if you provide library, it is most often not a single library in someone else's project. And if you strictly pin dependency and other libraries strictly pin dependency, you end in the situation when the dependency version mismatch and you cannot work. Maybe used by various teams. So the problem, you don't control the environment, the working environment. Even when I talk with people who are working in the company and they have, for example, standardized operating system, Python setup, etc., it happens that often that they have standardized in the given office, but in the second office in the other country, the setup might be different from different reasons. For example, they start updating the setup earlier and this team will be updated later. And in most cases, the library could be distributed as Python or conda package. How many of you know what is the conda?
Me too.
So many of these constraints which we have in the library are not valid in the context of project. On the project, you have much more control on the environment of development and production. However, having some behaving more like writing library is saving this pain of updating dependency because, for example, new NumPy version is 20% faster. And I use heavy NumPy in my data analysis project. And getting this only updating NumPy with solving the deprecation problems, speed up the whole project, reduce CPU usage, and so on. And also some libraries may be used as an application. Okay, so we have PyPy versus conda. So PyPI package is this how most of you are, I have hope, based on my experience with the conda, interact with Python installation. So this is the package you could install with pip install, UV, or maybe other tools, the poetry, add, etc. This is the default way of distributing Python code as a package, as a library. And it comes in the two file formats, the sdist, source of the package. This what you get by default, and this from which you should be able to run it. But the sdist is the problem, it is precompiled code. So if there is any setup steps of things to need to be done to adjust to a given operating system and so on, there is some execution of code done on the beginning of the installation. What are the problems? The first problem is that it's slow down. The installation is slower. The second, there is an arbitrary code execution during the installation. This is the security issue, especially when some installation process has some dependencies that might also be not pinned. So it means that even, for example, if you work in a company and you have strong security procedure, there is a problem because once will is checked, will is the static code. Will is the static code that you could unpack and use. As this is the code that is execute, which has dependency may be not pinned, it creates multiple security problems. So why not everything is the will? Because sometimes this what you need might differ from system to system. Especially at this moment, even if you have the will format for Windows, Linux, MacOS, I don't think that you could upload the file for BSD. You cannot upload file for Sigvin on the PyPI and so on. There are alternative registers, but okay, so what is more? These Python packages by default are configured by PyProject TOML or setupcfg or setuptools. If you still have some project on setupcfg, I strongly suggest to migrate to PyProject TOML. With setuptools also, it is harder to migrate some setuptools code, but minimalization and making the setuptools feel as small as possible is not only helping the potential user, but it's also helping your mental health. If you could put anything as a static metadata, put it as a static metadata, just. So then you will know that everything which is required in setup is dynamically calculated and without any problem. Well, not maybe without any problem, but there is a less code to read to find a problem and bug. Source. Okay. So there is multiple way to build things on PyPI. There is the most classical is build. There's a build package, and you could run python -m build, and it will build you and source this and will. However, build will you a will for current operating system. So for macOS and for Windows, there is higher chance that it will be portable, but it's not 100%. For Linux, it will be not portable, and you cannot even just upload to PyPI such things. This what I'm talking is about this problem with upload is for the packages with Python compiled extension. If your package is pure Python, you don't compile it, you don't have C extensions, you don't compile your code with mypyc or other tool to compile Python code, which for some of you might be interesting because from real case usage, mypyc speed up Python code 4 times. So in such situation, it is worth, but it will create this problem of compilation. If you would like to build this binary extension one, I suggest to take a look of CI build wheel or multi-build. It saves your time. It's so many common problems that comes in random moments that this tool solves. So what is the YPyP package? This is really simple for pure Python. You could easily set up your own server. So if you work in the company, if you don't want to publish something else, you could just to pip, UV, poetry, etc. You could provide additional index, and this additional index could be the directory on the network drive. It could be FTP server. It could be something other, and you could serve your own version of packages. But there's a problem that some packages that has compiled extension, there might be no wheel or no wheel on your operating system. This was, for example, big pain for early adopters of new macOS laptops with ARM processors, that for a long time there is no publicly available wheel, and they need to build everything on their machines. So these are the advantages. In the context, in the comparison with conda, there are these advantages. So the package author is fully responsible for building wheels. So from point of view of author, it's sometimes better. From the point of the user of the package which does not have enough love, it's sometimes a problem that some bugs should be fixed, and some build procedure, for example, is not the best one. I might talk about such a problem later, which I meet on my career. The size of the wheels. In the wheel, people pack every code which is dependency. So for example, if your code is usually using H5 library for access to H5 files, and you have few libraries, and you install from PyPI, it brings few copies of H5 library to your environment. In really rare cases, it might create some binary configs. I met it twice and a long time ago, so maybe it's solved on some way.
It still happens.
Okay. And last things is that sometimes when you install package, it might not work because it does not ship everything with it. It might require a system dependency. For example, the package, how many of you know Gravis? Okay, so Gravis is a nice library to create a graph, but Python wrapping to it is only allowing you to interact, but you are still responsible to install Gravis on your machine. It is stable. It is enough stable that it's not a problem of, for example, you have incompatible version of these two things, but it's a problem because you cannot install whole project by single command. As you might see, this remark from PyPI. So next is that we have multiple installers. This is some, I do not update this chart, so it maybe it's changed the performance speed. So there's UV, there's this new one. It is really fast. And I could told that it's almost production ready. So it means for many people it's production ready, but it might happen that your edge cases is not well supported. UV is the product of Astral SH company, this same company which produces RAF. It is extremely fast, not only because it's written in Rust, it's also because they do very smart things in the context of the algorithmical things. So if someone could put 8 engineers full-time for half year over the PIP, will be in much better place. Same with PDM or poetry. Half year of 8 engineers is really, they might really speed up everything. Of course, the UV might be even faster because of the language, but the chain differences will be much, much smaller. NTV is the part of the better toolchain. The founder company would like to do something like Rust C for Rust to do it for Python. When you go through the issues on the repositories, you might see that there is many today I learned moments about, oh, I don't even expected that people would like to use Python and in this way. So the speed of having ready project, I think, slowed down because of these multiple new things. But if you would like to test, check it, UV pip is almost replacement of pip. As you see, the other things also install from pip. Also, conda could install from pip, but then you might have really strange problems. But sometimes, if you hurry, you might not carry too much. Conda. So I see that most of you know. If any of you need to use the conda, I suggest to start using mamba. Mamba is the conda installer. It is, I could told, something similar as UV for pip. It's faster, it's written in C++, it works better. Conda gets some of the speed up because they start using mamba library for resolving dependency, but my experience is that mamba is better. What is the conda advantage? It ships not only Python packages, it ships everything. If you have multiple libraries which use, for example, this H5, we will have one copy of H5, because if they decide to update H5 to the newest version, they rebuild all packages that depends on it to have binary compatibility. So this is save this. They ship the programs like Graphviz, etc. They ship everything. Sometimes too much, because it happens that they ship the ls command. So you activate the conda environment, and magically your there's not in ls, but there are some tools that they ship, and there is a difference between Linux and MacOS. GNU Core utils and MacOS Query utils, and if you activate on the MacOS the conda, it might happen that you need to use the Linux syntax, not the MacOS one, which you use when the conda environment is not active.
What problem?
It's not a problem if you know about this. It's the problem. The problem is that when someone new comes to you and starts asking a question, and the person do not provide you one most important information, that the person activate this conda environment. Because if he activate different conda environment or does not activate any conda environment, the command that he has in the instruction works. And there is the last most important problem with conda, the licensing. If the companies are above 200 people, and anyone from these companies start installing things from the conda default channels, the company should buy a license. And even, for example, from the point of view of university, there is exception for classes, for providing classes, for preparation for classes and the students using, but there is no exception for people doing research. And you know, in the academia, you prepare the research and prepare the classes on the same machine. So if you would like to use it, and your company is not having the agreement with Anaconda Inc., you need to ensure that you use the Conda Forge. Conda Forge is community one, there is no fee, but I would like to highlight this from you because this is the legal problem, and so the environment in the conda is defined in package in the conda is defined with meta-YAML. It could be created by conversion from the Python package using Grayskull package. It works in almost every cases. If someone would like to have details, we could talk later. And it could be built by conda build, ratrel build, and uploaded to the conda forge registry. What is the Conda Forge? Conda Forge is the organization which is supported by Microsoft, for example. They provide their free credits on Azure pipelines. This is the community Conda server. It built packages which are based on the public sources. So there will be no your company inside package on it. And the difference is that the admin of Conda Forge could rebuild your package. And sometimes it happens that if there is some open source package on PyPI and the author of this Python package is not wanting to handle releasing on the Conda Forge, someone else might contribute configuration on Conda Forge of this package, and then there will be automatic bumping after each release, and some of the maintainer might update. So it might happen also if you don't take care about this Conda Forge package and some dependency bumping require rebuilding of your package, the Conda admin will do this without waiting on you too long. The releases of Conda Forge might be slower. The maximum which I meet is 1 year slower, because the new release required to rebuild, to bump many other things and rebuild it. It takes really long to find a volunteer to bump over 100 packages with complicated changes. It's not a trivial, bump and run, but C is red. Compilation failed. We need to do something with this. So there are 3 things which I could tell about Conda. There's a Conda, there's a Mamba. I suggest Mamba over Conda, and Pixi. Pixi is quite nice. It looks quite nice. I only play with it. I don't use it. They told that they are uniform package manager to install things from Conda and PyPI. For installing from PyPI, they use UV under the hood, if I correctly remember. OK. So you see, there are 2, and I talk long about Conda. Where Conda is still important? If someone working on Windows, set up the whole compilation stack, set up installation of multiple. If you work on the Linux and if you work on the MacOS, installing almost everything from PyPI is trivial. You sometimes need to run 1 or 2 additional commands. On Linux, you install from system repository. On MacOS, you install from brew. On Windows, you see article or information or install from Conda. And this is the reason why the Conda is still living, because sometimes it's better to do something faster than and maybe nuke environment after 1 month and to recreate it again than set up the whole C++ compilation and other language compilation stack on Windows. OK, build backends. So there is not only, we have package. This is only about the PyPI package. But you need to build this wheel, because wheel is something which is unzip and use. So the current installation way is, OK, there is wheel, unzip and use. There is no wheel, build a wheel, unzip and use. But it needs to have instruction how to build a wheel. There is a Python, so we don't have one way to do this. There is multiple way. So at some moment, instead of having instruction, OK, to install this package, you need to install this package and this, there's a decision. OK, there is a PEP 517, where we need to define what is required to build a wheel for this package. And you see that this is quite simple. Build system in PyProject Tom. It told which build system is required. The setup tools, the most classical one I put here. And told, OK, build backend is setup tools, build meta. So OK, this is not full list. This is the most popular things. But there are some reasons. Setup tools is classical. The most one classical, the oldest. It comes from multiple old projects which comes from years. There's Meson PY for a project that have compiled backend and are using Meson. Meson is the one of the tool to build C++ and other compiled code. There's a scikit build core. So this is the for CMake project. CMake is other library to build compiled code for C++ mainly. And there comes the hatchling. Hatchling is the response, okay, what we could do if we don't have to have backward compatibility with setuptools. We have knowledge and we would like to do it better. And also there's Poetry core for Poetry users, there is a fleet for fleet users, PDM, and other tools are available. What is really nice in this? You don't need to care what the build backend is used. In most situations, what the build backend is used by someone else's package. So in the distributed open source world, it is really nice because different project has different requirements and you don't need to care about this. Project metadata, this is what I told, PyProject TOML. The uniform way to store metadata and don't, because in the old days where the setup, I know there will be next slide. In the old days where the setup UI only worked, you need to execute setup UI to check basic metadata like dependencies, like author, etc. So when you try to resolve the environment, you need to download whole package and execute the setup UI to get this information. Now there is a PyProject TOML. You need to only read the static file. This is one of the reasons why UV is really fast, because if there is a PyProject TOML, they read sometimes only PyProject TOML from the sdist and resolve. And they, what I told, they even don't download whole source. They download the archive information, find where in the archive there is a part with the PyProject TOML, download only these bytes and check and use it in the resolver. And this is true. This was true during the PyCon.
No, it's not.
It's not true.
It's not.
They finally after 2 years, after a long time, I think 2021 it starts. So we are in the better place. Okay, we are in halfway to the better place, because now we need to convince people who are using Poetry to switch the metadata from a custom format to this one uniform one, which could be easy read by all other tools. Okay, and I will not talk about the latest feature which is accepted. This, I don't remember, maybe someone remember. A few days ago they accept the PEP about dependency which are not extras of the package.
Optional dependencies?
Yes, but not this optional dependency which are currently used. Oh, dependency groups.
Yeah.
So there will be nothing about dependency groups. I don't have time to understand fully what happens there.
It takes time.
Okay. So how we could work with the project management. This is the oldest. Now we have pip1. We have project. We don't have package. So we put dependencies into requirements txt. We set up the Python using the installer from python.org or from the repository and from conda or from multiple things. Run tests, you Python -m, unit test, pytest, stocks, nox, etc. Run application Python -m, this classical thing, or Python manage PY or something like this. And requirement spinning. This is what I will talk also. Pip compile. Okay, UV. UV is not fully in this place where they promised that it should be. There some features are still not implemented. Dependencies in PyProject TOML. Install Python with UV Python install. Run things using UV run But the problem with UV is in this moment that you need to write UV run and then PyTest, unit test, etc. They are still not allowed to define custom task, which, for example, Poetry can. You could told, okay, you can run the test task, and the test task will install all dependencies, etc. The UV do not know about this. And UV log for dependency pinning in their own format, which is also, I think that it might be accepted even in last days. And this will be something like hatch, but I think based on my experience, you could put here the hatch, poetry, PDM, etc. So still PyProject Tom. I'm not sure if PDM or poetry could install Python. Run test, hatch test, it's allowed to define. But for example, hatch still do not know how to pin dependency. It still need to use pip constraints or UV, for example. So there's, you see, the old approach, pip virtual requirements, PDM, poetry, RAI, UV, pixi. Why you don't want to have this old approach? My experience is that it allows switching to some more modern, allows to remove sometimes few pages of description. Someone needs only to manage the configuration in PyProject Tom or something like this, and do not need to remember to update also some document on Wiki, because if there is a CI and something is broken, the CI will be read and you know that it needs to be updated. I know that there is now a revolution of AI and big language models, but I don't yet found a CI which will be run and test your onboard instruction. And there is a PEP 723. It's really nice. You could put dependency in the comment on the beginning of the script. So if your application is single script.
It's a reiteration of a previous PEP that also attempted to do this.
Okay. Yes, I remember that. I'm not even sure if it's one or even more in the.
Suggested that, the author of Hatch.
But this is really nice. If you have single script, you don't split your code on the multiple things. You might just serve single Python file with such comment, and from day to day, more tools allow to run this. Okay, so elephant in the room. How many of you meet the situation that someday the CI becomes read everywhere? Okay. So for big projects, it's quite common. These many things what I learned told here, I learned on the Napari, where we have over 150 dependencies. And indirect also. Not direct is below 100, but not too much below. Okay, so what are the things? The avoid CI production crash. If you have continuous integration, continuous development, and some package intentionally or not intentionally release backward incompatible package. Maybe some of you know the XKCD comics with each release is breaking release. So it might happen that authors are fully convinced that the package is backward compatible, but in your case it's not backward compatible, because you depend on the bug that he. So dependency, this also CI is same like, okay, we need to set up some environment really fast. We have constraints. We could do this without any problem. And also, this is really important in the context of science. For example, when you need to install older version and you don't want to spend multiple hours to finding, because there is no upper constraints and there was a bug fix here in the meantime, but now it's not working. Okay, so simplest way, this is this dependency and we pin dependency. But as I told, for a library, this is not the solution, because other library might pin the scikit image in version 0.25, and you cannot create environment. And also, this is not supported in the toolchain, so you need to manually bump this. And also, last problem, when you install the scikit image, you see how many of the indirect dependencies there are. And all other dependencies are not pinned. And also, the scikit image version do not pin upper constraints, and I'm not sure, but maybe even this environment is not working correctly, because some of the package is too new. So, okay, we could put create requirements txt with everything. You know that there is a pip freeze command that you could dump your state of environment. Okay, it's really nice. You have pinned every package, so you could have reproducibility, but still you cannot easily bump it. And also, there are some dependencies which are system specific. So, for example, some of packages are using PyWin32 package, but only this is dependency which is installed only on Windows. So if you create you pin dependency on the MacOS or Linux, there will be no pin of this dependency. Okay, there is a constraint because previously we wrote pip install -r. Now there is a pip install -c. -c, so this is the constraints. So this is not what to install, but which additional constraints you need to take care during resolving of environment. Because, okay, what I told, okay, this is, no. And you see constraints could be created, like here. Okay, there is no mouse. There is a uv pip compile pyproject tom. No annotate, this is the command, or it could be, for example, pip compile. The difference is in the time. Once we on CI switch from the pip compile to uv pip compile, it was from 15 minutes to 20 seconds of creating multiple constraints files. It's not for one, but for multiple. So the constraints is really nice, as you see. It's created from PyProject TOML, so you could, for example, every week create it. And it's supported by multiple things. Because you could provide constraints to pip. We could provide constraints even, for example, to tox. Because tox, by default, allow to go environment flag below. So you could provide flag pip constraints, UV constraints to the tox, and Nox other libraries, so you still have dependency pinning. But you also see the PDM I think that I lost poetry example here. So you could provide it in the multiple way. So it's even nice because you provide the constraints, and if someone is using your library and needs to install older version of library, he could do this using his preferred project manager. It's not glued to single project manager, it works with multiple one. So there are log files. So UV, PDM, and Poetry provides log files. Maybe some other after last pip, but I'm not sure. These log files are nice. It better integrates than constraints. It integrates automatically. The user does not need to remember about providing the constraints. All people in the team are using the same version without any problem. However, when someone would like to use your work in his own project, there might be some incompatibility and problem to move it from one to another. Okay, so we could create a constraints. We could use the log files. The constraints support even whole syntax of requirements except of extras. So you could provide system-specific constraint, Python-specific version-specific constraints, or like other projects, for example, create 10 constraints files with information constraints, Python 3.9 something, and select based on the Python version. But does it solve all problem? Okay, this is what I told. There are some specific for a given operating system requirements. So simple generating constraints on one operating system do not work on another. This what again, if you try to provide single constraint, you need to remember to provide information about which Python version, because constraint might resolve to different version on different Python version. You see here all possible conditional things. So okay, there's also hashes. Hashes is for, because on the pip you cannot upload the next version of the SDs for a given requirements version, but you could upload the next version of wheel. For example, if something happens wrong and you need to rebuild the wheel again, you might create new version without creating new release of the package. Hashes are for ensure that the exactly same version is installed. This is the output of UV, which put hashes for all files. However, if you do default compilation with hashes, you get only hash for a given operating system. So if you do it on macOS, and it's, for example, NumPy, which has compiled well, it will be hash for a NumPy wheel on the macOS and will not work on the Linux. And okay, how many of you was forced to understand at some moment what these whole names mean? Okay, so what we see, this is the single NumPy release. NumPy, okay, it's simple. 2.1.0, it's simple, it's version. Okay, now we have pp, cp. Yes, this is CPython, this is PyPy. PyPy, which is Python in Python. Okay, 3.10, 3.13, this is the Python version, this is quite nice. pp7.3 is the version of the PyPy internal, because it's the 3.10 is that Python PyPy 3.7.3 is the equivalent of Python 3.10. And now we have the worst part. Here is Win, AMD64, Windows 64 bits. macOS 14.0. Okay, this is for the Mac in version at least 14 on architecture x86.
So at the same time, it's using x86 name and AMD64 name. So it's different.
Yes, because AMD64 is Windows one, and Linux and macOS is using x86-64.
At this point, I would be surprised if there isn't any like i386 somewhere in there.
Not in this version of NumPy, but if you go enough low, you will find it. Older version has this. They just drop buildings 32 bits. So you see that we have two versions of wheel for the Mac. One is for version 10.15, and one is for version 14. So if you have the latest version, which is 15, or not latest, but one before 14, and you install, you will get this wheel. But if your friend is stuck on the, for example, version 12, he will get this wheel. Yes, yes, because okay, there are multiple problems. And we come to the Linux things. So we have Mane Linux, and we have Mass Linux.
Why is the statically compiled one
What?
smaller? The statically compiled one at the end is smaller than the dynamically compiled one, which is second.
I don't know. Sometimes the bigger code is faster. Sometimes if you have more option in glibc, which is used for this one, you might have multiple paths in the binary code to call different functions from glibc. And when you have this one with musl, it might happen that, okay, there is there is no faster version which you need to select based on some things. You always call one single implementation. There may be multiple problems. So this is for normal Linux. Mane Linux is for normal Linux with glibc. And as it told, it required the glibc in version at least 2.17. And this is for Mass Linux. Mass Linux is using not glibc but musl C as a standard Python, as a standard C library, which is smaller, and it's not common for desktop or for laptops or something like this, but it's quite popular for Docker because it allows to produce much smaller Docker images. But you see that we have version of glibc problem, we have problem with musl C version.
I think there's also worth mentioning the free-threaded build, right?
Yeah. Okay. Okay, so there's also one additional thing. This is the CP38AB3. It means Python 3.8 plus. So this is not specific, but the version at most. Universal is something which works on both macOS and macOS ARM and macOS Intel. Okay, and for example here Mane Linux 2.28, so it's much newer version. And what I could show here, this two version, the 10.9 and 10.14. This, for example, is much faster because it uses OpenMP, and this do not use OpenMP, which is so it means that it's with parallel computation, and this is sequential only. Conda, you have this also things, and I got one question on the LinkedIn before in the first advertise. PyEnv vs UV. PyEnv install from source, so you need to have whole installation stack, compilator, and all the dependencies on your machine. But it might be faster because you have native compilation for your processor. Should have native, and you have CPython, PyPI, conda, Jython, multiple things from PyEnv. UV install from Python build standalone, so it downloads pre-built version of Python. So it needs to work on almost all processors, so it might be slower, but it's much faster, but it's only CPython.
I think PyEnv can also do pre-build.
Okay, maybe I don't use it in this way. And PyUV is not fully compatible with PyEnv virtualenv. So if someone asks me to use the PyEnv virtualenv and would like to use the UV also, might go to this issue and try to convince UV maintainers to decide if they want, and if not.
So is PyEnv virtualenv different than Python standard modules virtualenv?
PyEnv virtualenv stores the virtualenv in its own, not in the .venv, for example, directory, but in the PyEnv directory. So it means that if you use the PyEnv version, PyEnv local to set the things, you might use not only Python version, but virtualenv name version. So for example, you might have used the same virtualenv, for example, in few directories. And this is the source of the problem, because UV crash when it sees custom name instead of Python version number. I got information from organizers that there is some QR code for you to scan, and I put the questions earlier. I don't know if you have time, but if we don't have time to do it here, we could just.
We can have just one lucky question.
I have questions, if possible. I'm stuck with the conda. I didn't update since version 5, let's say, and current resolver doesn't work or work very slow. What is your recommendation? Go to mamba? Replace the resolver of conda with mamba, or?
Based on my interaction with conda, my suggestion is to nuke whole conda and install it from scratch using
Doesn't try to fix it?
No, because the big problem with conda of long living is that they store information about previous installation in log and also take account of it during resolving. So it might mean that if you have long living conda environment, it, for example, may still keep installing a really old version of some dependencies. And also my experience with conda is that you should never install anything in the default environment. Always conda env create env and work with the custom env smaller. Even if you would like to have only one environment, you should have base where you only update the conda and other toolchain for it, and you should have separate where you install your own things. Because my experience that once I try, or many things I try to help, is that in some moment it cannot be. The only solution is to totally nuke, and it's much more painful if you need to nuke your main environment than if you need to nuke sub-environment.
Okay, thank you, Grzegorz.